In this video, we'll go through exam questions that cover the criteria, calculate the volumes of cubes and cuboids. You can locate the questions on the mathsmaths.com website under level 1. The questions come from different exam boards. We'll start with the non-calculated questions and then we'll move to the calculated questions. Here is the first one. Rosa makes candles to sell. Each candle is in the shape of a cuboid of height 8 centimeters. So I'll quickly sketch a cuboid. So I'll sketch a cuboid quickly here. The height is 8 centimeters. The base of each candle is a square of perimeter 20 centimeters. So the base, which is this one here, that is a square in this case, and the perimeter is equal to 20. So perimeter is worked out by adding the 4 lengths, and as it is a square, these lengths are the same. So 4 lots of the side length will give us 20. So what is the side length? What is that number we multiply by 4 to give us 20? That is 5. So we now know that the length is 5 centimeters, the width is 5 centimeters, and the height is 8 centimeters. We're going to work out the volume of the candle. Now that is 5 times 5 times 8. So length times width times height. 5 times 5 is 25, which we're going to multiply by 8. Now, there are different ways we could multiply these. I could split 8 into 4 and 4, because 4 lots of 25 give us 100, and another 4 lots of 25, which is 100. So in total, that is 8 lots of 25, which is 200. You can also use the long multiplication method, which still is going to give you the same answer. So 200 centimeters cubed. Don't forget, we multiply in 3 dimensions: length, width, and height. So it's 3 of them. That's why we have this 3 here, cubic centimeters. Use reverse calculations to show a check of your answer. Reverse calculations means doing the opposite, going backwards. So we multiplied, now we're going to divide. So I'm going to do 200 divided by 8. How many 8s fit into 20? That is 2 of them. 2 lots of 8 gives us 16. So we have 4 remaining. How many 8s into 40? That is exactly 5. So that gives us 25, which shows that we've done the calculation correctly. Kiara needs a container to put in her freezer. She sees this container. The container is in the shape of a cuboid. Kiara knows 1000 cubic centimeters equal 1 liter. She thinks the container holds more than 3/4 of a liter. Is Kiara correct? You must show your working. So we'll first work out the volume of the cuboid, and then we'll convert that into liters. So we've got these dimensions: 20 centimeters, 8 centimeters, and 5 centimeters. So we'll multiply the 3 of them. Now we know that order doesn't matter when you do multiplication. So I could do here 20 times 40, because 8 times 5 is equal to 40. Now it's easy for me to multiply, because I can do 2 times 4, which is 8, and add the 2 zeros. So that gives me 800 cubic centimeters. So now we know that 1000 cubic centimeters equal 1 liter. What about 800 cubic centimeters? That would be less than a liter. What part of it? That will be 0.8 liters. It'd help if I put this on a number line. So there is 0 and here is 1. And there is 0, that's 1000 cubic centimeters. So underneath, with 0 and 1, they represent it in decimal form. So half of 1000, that is 500 cubic centimeters, which is 0.5 as a decimal. And in this case, we're talking about liters, so that is 1 liter, and that's 0.5 liters. Now 800 will be about here, which is also 0.8 liters, as we've seen. She thinks the container holds more than 3/4 of a liter. Is she correct? So 3/4, that will be about here, which is 750 cubic centimeters. And as a decimal, that's going to be 0.75. So we've got 0.75 liters, which is less than 0.8 liters. So the container holds more than 3/4 of a liter, and she is correct. What is the volume of this cube? So we've got side length 10 centimeters. So width will be 10 centimeters and height will be 10 centimeters because this is a cube. So to work out the volume, we'll do 10 times 10 times 10. 10 times 10 is 100. 100 times 10, that is 1000. So it's 1000 cubic centimeters. The volume of this cuboid is 24 cubic centimeters. What is the value for the depth D? So we're given length and width. So that is 4 and 3. We don't know depth, so I'm going to leave a gap there. But if I multiply the 3 of them, the answer is 24. Because that's what we've been told. So 4 times 3 is 12, times the missing number gives us 24. What is that number we multiply by 12 to give us 24? That is 2. Because 12 times 2 gives us 24. In other words, it's like dividing 24 by 12, which gives us 2. Now you can check. 4 times 3 is 12. 12 times 2 is 24. The sports club needs to replace the sand in a long jump pit. The groundsman works out the capacity of the long jump pit to order enough sand. What amount of sand does he order? Put units on your answer. So we need to work out the volume, and we've got the 3 dimensions. 8 meters by 3 meters by 0.5 meters. So we're going to multiply 8 by 3 by 0.5. 8 times 3 is 24. So 24 times 0.5. When you multiply a number by 0.5, you halve in it, because 0.5 is half. So 24 times 0.5 gives us 12. What is the volume of this cube? So a cube will have these equal dimensions. So we're doing 5 times 5 times 5. 5 times 5 is 25. So we'll do 25 times 5. Five times 5, again 25. So 5 down, 2 carried over. 5 times 2 is 10, and the 2 is 12. So 125 cubic centimeters. Work out the volume of this cuboid. So we're doing 8 times 4 times 5. 8 times 20, because 4 times 5 is 20. We could do these in any order we like. So 8 times 2 is 16. Add the 0, gives us 160. So this is 160 cubic centimeters. We now move into the calculated questions. Asha needs to buy a pair of cycle bags for a trip. She reads an article which says that for a cycling holiday, the cycle bags need to have a capacity of at least 20 litres each. 1 litre is the same as 1000 cubic centimeters. Asha sees some cycle bags which each have these dimensions: height 42 centimeters, width 32 centimeters, depth 17 centimeters. The cycle bags are roughly cuboid in shape. Are these cycle bags large enough? Show your working. So we'll work out the volume of the bag and then work out the capacity in litres. So we've got the dimensions: 42 centimeters, 32 and 17. So we'll do 42 times 32 times 17. Which is 22,848 cubic centimeters. 1 litre is the same as 1000 cubic centimeters. So if we divide 22,848 by 1000, should give us the number of litres, which is 22.848. This is greater than 20 litres, which was the recommended capacity for the cycling bag. So we're going to say, yes, these bags are large enough. Reg wants to make a cake shaped like a dinosaur for his son's birthday party. He looks online and finds this dinosaur-shaped cake tin for sale. Reg thinks, I like this tin, but I don't know how much cake mixture to make. My recipe is for a 20 centimeter square tin that is 8 centimeters deep. What is the volume in cubic centimeters of a 20 centimeter square tin that is 8 centimeters deep? So you can imagine a tin that looks like so. So it's 20 centimeters long, 20 centimeters wide, and 8 centimeters deep. So we'll do 20 times 20 times 8. Which is 3,200 cubic centimeters. Antihiser skip. The skip is cuboid. It is 1.25 meters wide, 3.6 meters long, and 1.6 meters deep. What is the volume of the skip in cubic meters? So we'll do 3.6 times 1.25 times 1.6. They're all meters. So that is 7.2 cubic meters. A sales rep needs some cardboard boxes to store samples at work. The office supplier has 3 different sized boxes. Which box has the largest volume? Explain your answer. Include figures to support your explanation. So we've got box A, which has width 35 centimeters, length 35 centimeters, and height 55 centimeters. So the volume of A will be 35 times 35 times 55, which is 67,375 cubic centimeters. Then we've got B with dimensions 40 centimeters, 40 centimeters, and 40 centimeters for width, length, and height. So we'll do 40 times 40 times 40, which is 64,000 cubic centimeters. Now C has dimensions of 30 centimeters, 60 centimeters, and 30 for length, width, and height respectively. So we'll do 30 times 30 times 60, which is 54,000 cubic centimeters again. Which of these numbers is the largest? That is 67,375. So that means box A has the largest volume. We've got to give an explanation, so we're going to say that 67,375 is greater than 64,000 or 54,000 cubic centimeters. A garden is to buy compost to fill this tub. The diagram shows the dimensions of the tub, which are 0.5 meters by 1.8 meters by 0.25 meters. They buy compost in 50-litre bags. 1,000 litres equal 1 cubic meter. How many bags of compost must they buy? So we'll work out the volume first by doing 0.5 times 1.8 times 0.25, which is 0.225 cubic meters. 1 cubic meter is equal to 1000 liters. What about 0.225 cubic meters? How do we get from 1 to 0.225? That is by multiplying by 0.225, because 1 times 0.225 gives us 0.225. So we'll do the same on this side as well. 1000 times 0.225, which we know that gives us 225 liters. And compost comes in 50-litre bags. So to work out how many bags they need to buy, we are going to do 225 divided by 50. Which is 4.5 bags. So I'm going to say 5 bags, because you can't buy part of a bag and you can't buy less, so it's okay to buy a bit more. Work out the volume of this cuboid. State the correct units in your answer. So we've got the dimensions of the cuboid. We're going to multiply them together to get the volume. So 8.58 times 8.35 times 12.13. They're all in centimeters, so we can just multiply. And that gives us 869.029 59. So I'm going to say 869 cubic centimeters, because we input centimeters. The site manager needs to order cement for the base of the building. The base will be 120 millimeters thick. Concrete costs £85 per cubic meter, and any amount can be ordered. Calculate the cost of the concrete needed for the base. Show you working out and write the answer in the box below. So we've got the base of the building, which measures 20 meters by 15.2 meters. So you can imagine this looking like so. So the base is shown here. So that would have length 20 meters, width 15.2 meters, and we've got the depth or the height or the thickness being 120 millimeters. Now that's a different unit, so we need to convert it before we do any calculations. So 120 millimeters, that will be 12 centimeters, because there are 10 millimeters in a centimeter. Now that is, in meters, 0.12. You can divide 12 by 100 and it's going to give you 0.12. Why divide by 100? Because there are 100 centimeters in a meter. So depth here will be 0.12 meters. Now we've got all three dimensions in meters, so we can just multiply them to work out the volume. So 20 times 15.2 times 0.12 gives us 36.48 cubic meters. The cost is £85 per cubic meter, and any amount can be ordered, so you don't need whole numbers. So I'm just gonna use 36.48 that we got here, multiplied by 85, which is 3100.8. So as this is money, I'm going to write £3,100 and 80 pence. The cement company adds a 5% delivery charge to the cost of all orders. What is the total cost including delivery? Show your working out and write the answer in the box below. So £3,100 and 80 pence was the cost that we've just worked out. Now we need to add 5% delivery charge. So we're working out 5% of 3,100.8. So 5%, that is 5 out of 100. Which is also 0.05 of 3,100.8. That is £155 and 4 pence. So we're going to add this now on top of £3,100 and 80 pence. Which is £3,255 and 84 pence. You use a lot of water while working. You buy in some new containers to hold the water that you use. The containers are cuboid. They have a base of 32 centimeters by 21 centimeters and are 0.5 meters tall. You need enough containers to hold at least 100,000 cubic centimeters of water. Each container costs £6.99. How much will it cost to buy the containers that you need? Show your working out and write the answer in the box below. So we're working out the volume of the container, and we've got 32 centimeters, 21 centimeters, and 0.5 meters, which we need to convert into centimeters. So 0.5 meters, that is half a meter, that will be 50 centimeters. So 32 times 21 times 50 gives us 33,600. And you need enough containers to hold at least 100,000 cubic centimeters of water. So what we're going to do is 100,000 divided by 33,600, which is 2.98 containers. Of course, you can't get part of a container, so we're going to say 3 containers. At £6.99 each, gives us 20.97. So that is £20 and 97 pence. A playground needs wood chips to be laid under the swings for safety. The area of the swings measures 13 meters long and 5 meters wide. The wood chips need to be 10 centimeters deep. The wood chips are delivered in the following bags, which hold 1 cubic meter of wood chips and cost £99. Only full bags can be bought. What is the total cost of the wood chips needed? Try your working out and write the answer in the box below. So the area measures 13 meters long and 5 meters wide. And we've got 10 centimeter depth. So in terms of meters, because we need to use the same unit, that is 0.1 meters. It's like 10 divided by 100. So to work out the volume, we'll do 13 times 5 times 0.1. Which is 6.5 cubic meters. Wood chips can be bought in bags like this, which hold 1 cubic meter, and only full bags can be bought. So we're talking about 7 bags. Each bag costs £99. So we'll do 7 times 99, which is 693. So £693. You are making a stand to put a fish tank on. This is a sketch of the stand. Each piece of wood measures 5 centimeters by 5 centimeters. You need to consider these measurements when calculating the lengths of wood needed for the side pieces, legs and bottom lengths. You estimate that the total length of wood you need to build the stand is 7 meters. Is your estimate correct? So we'll add all of the lengths together. Starting at the top, we've got these 2 top lengths, which measure 1.2 meters each. So we'll do 2 times 1.2, which is 2.4 meters. We have 4 side pieces, these ones. It says 0.3 meters here, but that is from one corner to the other. So we're going to have to take away this bit here. And that is equal to 5 centimeters, as we're told here. So 5 centimeters in this corner and another 5 here, that will be 10 centimeters. So 10 centimeters, that is 0.1 meters, like dividing 10 by 100. So if I take that away from 0.3 that we have, we're left with 0.2. So 0.3 take away 0.1 gives us 0.2. So there are 4 of these. There is this one, this one, this one, and this one. So that is 4 times 0.2, which gives us 0.8. So we've done the top length and the side pieces so far. We now have the legs, and we're told that from this point to this point, which is the whole leg, that is 0.54 meters. And we have 4 legs. So that's going to be 4 times 0.54, which is 2.16. Now we've got the bottom lengths. So we know that from this point to this point, that is 1.2 meters. But we need to take away again 10 centimeters, which is 0.1. So 1.2 take away 0.1 gives us 1.1, and it's 2 of these. So 2 times 1.1 gives us 2.2. Now if we add all of these together, 2.4 add 0.8 add 2.16 add 2.2 gives us 7.56 meters. Now the question is 7 meters enough? So you estimate that the total length of what you need to build the stand is 7 meters. Is your estimate correct? We're going to say no, because we need more than 7 meters. Now you need to show the working out within the box, but I had to show it there so I didn't need to scroll up and down. You need to fill the fish tank so that it is 2/3 full. You use a 2-gallon bucket. 1000 cubic centimeters equal 1 liter. 1 gallon is equal to 4.5 liters. How many buckets will it take to fill the tank to 2/3 of its capacity? Show your working out and write the answer in the box below. Let's work out the full capacity first. So we've got 120 centimeters, 55 centimeters and 30. So we're going to multiply them. 120 times 55 times 30 gives us 33,000. That is cubic centimeters, because we input centimeters. 1000 cubic centimeters equal 1 liter. What about 33,000 cubic centimeters? So we'll do 33,000 divided by 1000, which gives us 33. So 33 liters. Now we also know that 1 gallon is equal to 4.5 liters. What about 33 liters? How do we get from 4.5 to 33? So we'll do 33 divided by 4.5, which is 7.3, 3, and so on. So 3 is recurring. So we'll do the same here now, which gives us the number itself, which is 7.33 gallons. That is the full capacity. To work out 2/3 of it, we're going to divide it by 3 and multiply by 2. So divided by 3 times 2 gives us 4.89 gallons. And you use a 2-gallon bucket, so we'll do 4.89 divided by 2, which is 2.445. So we're going to say 3 buckets. Davender has received an order for 100 bracelets. She packages each bracelet into a box 10 cm by 8 cm by 3 cm. Davender will put the 100 boxes of bracelets into larger boxes for postage and delivery. She has a choice of box A or box B with measurements as shown below. She will only use one size of box. Box A costs 70p each and box B costs £1.80 each. She wants to spend as little as possible. So we've got box A and B and their dimensions. Should Davender choose box A or box B? Show your calculations and the workings out in the box at the top of the next page. I'm going to show the working out here so that I don't need to scroll up and down. So we've got the 2 boxes with the respective dimensions, and we also have the size and the dimensions of the small boxes that she puts each bracelet in. So that is 10 centimeters by 8 centimeters by 3 centimeters. So 10 by 8 by 3. So we'll work out how many of these small boxes fit into box A. So we've got the length, which is 50 centimeters, and the length of the small box is 10, so we can fit 5 into that. So I'm going to show here roughly what that looks like. The width is 8 centimeters for both, so only one can fit along the width, and the height is 12 centimeters. I've got 3, so 4 of them can fit along the height, so it will have 4 rows like so. So let's work out how many in each row. That will be 5 in each row, and there are 4 rows, so 5 times 4, that will be 20. So 20 in box A, and 100 of them are needed, so that means we'll need 5 boxes to fit them all in, because 5 times 20 gives us 100. The cost per box is 70p, so 5 times 0.70 gives us 3.5, so that is £3.50 for box A. Looking at box B, the length is 50 centimeters, and that means we can fit 5 of the smaller boxes into it, just like for box A. The width is 16 centimeters, so we can fit 2 of them. So this goes like so. And the height is 15 centimeters, so we can fit 5. So this looks like so. So in each row we have 10, and we have 5 rows. So that is 50 small boxes in box B. So we only need 2 of these, because 2 times 50 makes 100. Each of these boxes costs £1.80, so we'll do 2 times £1.80, which is £3.60. £3.50 is cheaper than £3.60, as she wants to spend as little as possible, so we're going to choose box A, and we've shown why. A cuboid measures 7.6 centimeters by 2.25 centimeters by 5.4 centimeters. Work out the volume of the cuboid. So we'll multiply the 3 dimensions, 7.6 by 2.25 by 5.4, which is 92.34 cubic centimeters. There will be a pond for fish in the garden. The pond will be a cuboid of length 2.5 meters and width 1.8 meters. The pond will be filled with water to a depth of 1.2 meters. 1 cubic meter is equal to 1000 liters. Each fish needs 360 liters of water. Work out the maximum number of fish that can be kept in the pond. So we'll work out the volume first and then the capacity in liters. We've got the dimensions being 2.5, 1.8 and 1.2. So we'll multiply them. And that gives us 5.4 cubic meters. We know that 1 cubic meter is equal to 1000 liters. So 5.4 cubic meters, if we multiply them by 1000, that will give us 5,400 liters. So that's how much water the pond holds. We'll do now 5,400 divided by 360, which is how much water each fish needs, and it will give us the number of fish that can be kept in the pond. So 5,400 divided by 360 gives us 15. So that's the number of fish that can be kept in the pond. Brandon wants to buy a box large enough to hold 16 kilograms of flour. He uses this formula. Volume of container in cubic centimeters is equal to weight of flour in kilograms times 2,400. He sees this cuboid box for sale. So let's work out the volume of the box first by doing 30 times 35 times 40, which gives us 42,000 cubic centimeters. So we now know the volume of the container or the box that we have, and that is 42,000 cubic centimeters. Let's work out what is the volume of the container that is large enough to hold 16 kilograms of flour. So we're going to replace weight of flour in kilograms with 16, and we're going to multiply it by 2,400. Which is 38,400. So a container that has this kind of volume, at least this volume, will be large enough. And 42,000 is greater than 38,400. So can this box hold 16 kilograms of flour? We're going to say yes. And that's the end of the questions.